Presentation, okay, will be on all right, tuna processing. All right, previously it's actually shrimp, now it's actually tuna. All right, tuna processing model at a household scale industry in the coastal border area of Indonesia, Timor Leste. All right. Okay, so the presenter is ready. Can start.
Okay, thank you, Dr. Lau, the Honorable Chairman of this session. Distinguished speakers, good afternoon, ladies and gentlemen. I would like to say thank you for coming to my presentation. It's great to see you all in this virtual conference. Let me introduce myself. I'm Chaterina Paulus, a lecturer in Nusa Cendana University in Kupang, East Nusa Tenggara Province, Indonesia. So it's already. Mrs. Santi, may I share my screen? Because there's some running programs in PowerSim.
Yeah.
Thank you. In this opportunity, I would like to present our research entitled Tuna Processing Model at Household Scale Industry in Coastal Border Area of Indonesia and Timor-Leste. So why am I telling you about this research? What I'm conveying right now is the result of my research at the border between country and in East Nusa Tenggara Province, with a focus on processed tuna products in the form of floss and jerky, with the hope that this result of research will give confidence to local government and also to coastal communities that household scale tuna processing is very prospective and profitable. Due to time constraint, I continue to slide 8. I begin by showing you this distribution map of the fish processing industry in Indonesia. Take a look at this map. Most of the fish processing industry in Indonesia is still very low. In this figure, it can be seen that East Nusa Tenggara Province is in the lowest zone of the fish processing industry, even though fish production in East Nusa Tenggara Province is abundant. So that the purpose of my research is to find out the projection of processed tuna production, calculate the income of border coastal communities from tuna floss and tuna jerky business. And the research location is in 4 border coastal villages in Belu Regency. I collect data from 2018 to 2020, where I got data sources from surveys, FGDs, and field trials involving the local community. So I made a model with dynamic system approach from 2012 to 2030. Now let's turn to the proposed policies and scenario. Let me expand on this point. As seen in this slide, there are 3 scenarios and 3 policies proposed for each of the existing scenarios, with an assumption that the ability to catch tuna is only 300 tons per year, based on available data. First of all, I talk about doing business as usual. The doing business as usual scenario is an existing condition in which the proposed policies to increase tuna catches as well as policies to increase the production of tuna floss and tuna jerky has no assistance at all. And there is no technological innovation in processing, meaning that people are still using traditional methods, both in processing tuna floss and tuna jerky. Second, we look at the moderate scenario. The moderate scenario is a development condition in which the proposed policies in increasing tuna catches, there are assistance of ships and fishing gear, thus will have impact on the policies to increase tuna catch production. Namely, the condition applied to increase the amount of yellowfin tuna raw materials to 30% of consumption quota. And to increase the production of tuna floss, the use of Japressing technology as a pressing tool is applied. So there is a subsidized for electricity cost. There are sanitation guidance and assistance as well as the quality of fishery product processing. Meanwhile, to increase the tuna jerky production, the treatment given is increasing the amount of yellowfin tuna materials to 10% from consumption quota using electrical tray dryers, subsidizing electricity cost, guidance and assistance in sanitation, as well as the quality of fishery product processing. And finally, for the optimistic scenario is the maximum condition in which to increase tuna catch, treatments are carried out such a full assistance of ships, fishing gear, fuel subsidy, and the use of capture technology. To increase the production of tuna floss, the condition applied to increase the amount of yellowfin tuna raw material to 50% of consumption quota, use Japresic as a press tool equipped with solar panels, halal certification and distribution permit from National Drug and Full Control Agency is the business licensing, partner in product marketing. Then, to increase tuna jerky production, the condition applied to increase the amount of yellowfin tuna raw materials to 20% of consumption quota, use solar dryer dome, also halal certificate and distribution permit from National Drug and Full Control Agency is the business licensing, partnerships in product marketing. So let's get started. I will go to PowerSim Studio. Just wait for a second. I'll change the PowerSim Studio program. Hopefully it won't be long to wait the program. Okay, it's already here. So this is the initial view of the model that I made. I am using PowerSim Studio 10 academic version. And we go to the causal loop diagram. This chart clearly show a causal loop diagram. We can see the variables that affect this model. And we continue to stock flow diagrams. Here, I divide this processing model into 3 submodels, namely yellowfin tuna stock submodels, the tuna floss industry submodels, and the tuna jerky industry submodels. I have applied this model to our guided group Azmanajaya in Belu Regency. And to support this model, we create the technology electromechanic fish press table, or called Japresic. In Bahasa, we call meja press ikan elektromekanik, which has been patented in Indonesia. And we also made a flyer with an information about tuna floss and tuna jerky products. This is a picture of floss and jerky products that have been marketed both locally and sold to a neighbor, Timor Leste. And then we go straight to the simulation of the yellowfin tuna stock. Here we can see in figure 1 shows the yellowfin tuna stock, and the red line is the total of yellowfin tuna stock, and the real data period we get is 2012 until 2017. Here it can be seen that there was a decline in tuna stock. And the explanation for figure 1, based on the data, the tuna fishing in Belu Regency can be seen in figure 1. It has reached the production quota in 2012, so that government policies in the form of limiting tuna fishing caused a decrease in tuna production, until finally in period of Ibu Susi Pujiastuti, the Minister of Marine Affairs and Fisheries from 2014 to 2018, began to pay attention to sustainable fisheries management, and thus there was an increase in catch production. And by using this data, we can project until 2030. And in a business as usual scenario, catching yellowfin tuna reached the quota in 2028. Some of the captured tuna are exported and some are consumed. In figures 2 and 3, I want to show that tuna used as raw material for making floss and jerky is still far from the consumption quota, meaning that the raw material for floss and jerky are still widely available in Belu, so it is very promising if produced optimally. Then we continue to tuna floss submodels. In figure 2, you can see the benefits obtained from the tuna floss in the home industry. In 2030, the income of 961 million rupiah will be obtained with a production of tuna floss about 9.72 tons. Then the tuna floss industry started to exist in Belu 2016. Previously, there was no tuna floss industry in Belu. In figure 3, you can see the investment costs required to process tuna floss, while in figure 4 are the operational costs incurred to processing tuna floss. Now we try to simulate F is for fraction. We run step in 2012 until 2022. And for example, in 2022, we carry out a moderate scenario on F fishing, F tuna floss, and F tuna tech tuna floss, where in F fishing there is an assistant of ships and fishing gears. Then the F tuna floss is treated, for example, in increasing the amount of yellowfin tuna raw materials to 30% of consumption quota. The using of japresi as a pricing tool, and subsidizing electricity costs. Also, there are guidance and assistance in sanitation and quality of fishery product processing. Then there is an increased income in figure 2, which was previously 961 million rupiahs to 3.3 billion rupiahs in 2030. In figure 3, investment has increased, but as seen in figure 4, operational costs have decreased due to the application of japresi technology. This scenario increased the number of workers from 23 to 40, from 23 to 64, and business groups from 5 to 13 groups. And by using this model, we can vary various scenarios in its policies. Next, we look at the tuna jerky submodels. We can do the same treatment as tuna floss submodels. The same as tuna floss industry, the moderate scenario is applied 2022. Then in 2030, there will be increase in income of 500 million rupiah from 270 million rupiah, with a production capacity of 9 tons from 4.5 tons. In figure 3, investment has increased, but as shown in figure 4, operational have decreased due to the implementation of technological innovation. This has increased the number of workers from 23 to 45 and business group from 5 to 9 groups. We can simulate various scenarios for each policies to see the projection that will occur as a result of the implementation of the policies. Okay, back to slides. Last but not least, before we finish, I'd like to leave you with some policies recommendation based on simulation results of the previous model. There are 8 policies that we propose to government so that the processed tuna business in the form of floss and jerky becomes superior commodity for coastal border community between Indonesia and Timor-Leste, other than sopi, as you know, the famous traditional drink, and M.Si, a typical food made from beef or pork. And because this business is very profitable, I invite all of you to invest in processed tuna floss and tuna jerky products in Belu Regency. Thank you very much for your attention. If you have any questions, I'm happy to answer them now. Dr. Lau, please, the floor is yours.